Welcome friends in lecture 6 science lesson 3 metals and non-metals. In today's topic we are going to learn about, we have learned in the previous lecture about the reduction, that is roasting calcinations are the two methods from which we can have oxide formation, and after that from sulfides and carbonates, and after that we reduce the elements by electrolysis method in a very pure state, by carbon or by reactive elements or by heating only. So we have learned the reduction of metals. From that we have an impure metals. So whatever the impure metals we are having it, furthermore we are going to refine those metals. So the metals obtained by various reduction, that is refining of metals obtained by various reduction processes is actually not pure in the reduction process. So the impurity must be removed for obtaining pure metals. Using electric current we refine these elements is called as an electrolytic refining. The metals we have written it, copper, zinc, tin, nickel, silver, gold, etc. are the metals which are used can be refined from this particular electrolytic refining method. I have drawn a diagram for which this is a container, that is a tank, right, and this is a big tank in which the impure metal, impure element, that is a copper impure metal, is kept at anode, connected as a positive terminal of the battery, and on the negative terminal of the battery the a copper pure metal strip is connected. The solution of the same copper metal ion, that is copper sulfate, here in this case acidic sulfuric acid, is taken. Now as you see here in this particular process, the negative terminal is here. This is a negative terminal and this is the positive terminal. So from the negative terminal the electrons are passing and going towards a pure metal strip known as cathode, because this is negatively charged, because the electrons are coming here. Now as the electrons are coming here, you see from the solution of copper sulfate, that is CuSO4, Cu2 plus from the sulfate ions gets accumulated here by taking an electrons from this particular cathode. So you may see that the sulfate ions get free here. So these sulfate ions, because of the higher concentration, because from the sulfuric acid you have sulfate ions and copper sulfate also we have sulfate ions, gets accumulate towards anode and start taking copper from this particular impure anode. Fine, that is an impure metal. The copper is being selectively taken and gets back to the solution again. So the copper from the solution goes to the pure metal, and from impure metal gets back to the solution. So this is how you may see the accumulation of the copper here. On this particular area you see the accumulation of copper here, and you have a lot of accumulation of copper in this particular electrode. Fine. So you may see this here, that an accumulation happens here of the copper. So here the accumulation of pure copper happens and we have an higher formation, and this gets degraded. This particular anode gets degraded and this copper is getting accumulated here continuously. So we may see in the form of an reaction also. So one more thing, that the another elements which are there as an impurity here inside this gets accumulated at the lower base is called as an anode mud. Fine, this is called as an anode mud, which gets accumulated in the lower side. So at anode we have an impure metal bar of copper. At cathode we have a pure metal strip only, very small. If I say the percentage, it may be not 5% of this particular entire thing. Now electrolytic solution that we have taken is copper sulfate and sulfuric acid in minor proportion. So this is an acidic copper sulfate. Now whatever we get as an impurity here at the last contains iron, platinum, gold, silver kind of elements here, that is refined later on. Now what the reaction happens basically, as I have tried to written it, at anode what happens, the copper loses 2 electrons here from this particular impure formation, loses electrons and gives to its own rod. So the electron passes from here, and you may see that the electron it gets accumulated at anode. So what happens in the solution here basically, that whatever the copper is there which is losing electron and going to the sulfates and forms copper sulfate. You may see here copper reacting with sulfate ions forms copper sulfate. Fine. So this is what happens at anode. Now if you see at cathode, Now if you see at cathode, what happens at cathode here? Here it is a cathode. So cathode, you may see that the 2 electrons is taken by from the solution. The copper 2+ condition goes to cathode, takes 2 electrons and turn to copper. That means it gets accumulated here, as I have tried to shown in the diagram. So what happens here in this solution, that the copper sulfate solution gets ionized and form copper sulfate and sulfate ions. From this particular, here the sulfate ion goes and gets accumulated here. So this is how this process of electrolytic formation happens, and from that the pure metal is being collected. It may happen with zinc also, it may happen with tin, nickel, silver, gold, any element. Fine, but we have to take the electrolytic solution of that particular substance. The next topic that we are going to take here, you see in corrosion, the metal reacts with oxygen, moisture and acid. The 3 of the formations are there basically. Now in corrosion, metal reacts with oxygen, moisture and acid, etc., and gets corroded, right? So it gets corroded here. Now the silver metals reacts with oxygen in air and forms black coated, that is silver oxide. The same way metal reacts with sulfur also and forms silver sulfide, fine, and this also is no more silver and forms silver sulfide, which is getting corrosion. Now copper also reacts with air carbon dioxide slowly and slightly turn from brownish substance and gains green coating and turns to copper carbonate. So this green coating is poisonous, so that's why don't cook in copper vessels, because it gets corroded. In iron is the main exposure getting problematic. So iron is a big rusting formation happens because we make many things from iron. So iron gets exposed with air and moisture and forms a coating of brown flakes. Substance is called as an rust. The formula of rust is Fe2O3.XH2O. Now what we can do from corrosion prevention? So the prevention are the different steps can be taken for corrosion to be getting prevented here. So first of all, for rusting of iron can be prevented by painting on it, that we do put color, oiling on it, greasing, that is a grease that is on cycle chains and on what we put a grease on, chrome plating, that can be another method by doing a plating on it. Then galvanizing, this is another form of plating but done with the help of zinc. So zinc is coated on steel and iron, so it stops getting rusted. We have to sacrifice zinc, that is a sure thing, but for sacrificing zinc we get an protection on iron. Now the another reason, very important thing, is alloy making. Now what is an alloy making is like iron is mixed with carbon. It's an homogeneous mixture. Basically alloy is an homogeneous mixture of 2 elements that we have learned in previous lectures. So iron plus carbon, in 0.05% of carbon is mixed with iron, so it becomes very hard and strong from the soft metal, which can be also stretched by getting slightly heated. So pure iron can be heated and can be stretched, but if we mix with carbon, it turns to basically steel, and this steel is turns to very hard. If you increase the percentage of carbon from 0.05 to 0.1%, to up till still more, it turns to more and more hard element. Fine. So this is an type of an alloy used for different purposes. Also in household purposes we use steel that is called as an stainless steel, that we use an equipments of stainless steel for different purposes in our house, like steel glass for drinking water. So iron plus nickel plus chromium, it does not contains carbon, it's a mixture of iron, nickel and chromium, that is called as an stainless steel. This is only steel and this is stainless steel. They do not rust, as we put inside the water also and keep for very long time, they do not rust. So maximum of the utensil used for household purposes are all stainless steels only, because they do not rust in with water. Fine, and becomes hard also, that is being utilized. Now in case of gold, the 24 karat gold cannot be used for making ornaments. The reason behind it is very soft. So we put 22 parts of gold and 2 parts of silver, and this is why that we call this as an 24 karat gold. And after that it becomes hard and it is utilized for making ornaments. That is 24 karat gold is called as 999 and this is called as 916, 22 karat gold. Fine. Here one metal, if it is mercury, then this mixture is called as an amalgam. These amalgams are used in button cells that we are using in wrist watches, calculators and all. So it is called as an amalgam. This is also used as a mixture and as an alloy. Also copper plus zinc is called as brass, and this is used for electrical circuits. Fine. So this particular thing is used for electrical circuits. Copper plus tin is used as a poor conductor in the electrical circuits, where we do not require a high amount of current to be passed. We use this particular mixture that is known as bronze. This particular mixture is basically called as an bronze. So this mixture is bronze. Fine. Furthermore, lead plus tin is another alloy which is used for welding purposes for electrical wires, due to its low melting point, where we have a problem where the circuit is broken and we have a circuit on which the capacitor, resistance and all need to be fitted here. We use for this particular welding purposes in electrical circuits for its low melting point, so it does not damages the circuits. Fine. So hope so you must have learned many things from this particular video, and we have finished this chapter. Fine. So you may write down these question answers also and prepare this chapter nicely. Thank you.